find sine C in terms of A and H.
Okay, so sine we know is so this is trigonometry. So sine is the opposite over the adjacent.
Yeah.
So sine C.
Hang on. So SOHCAHTOA.
Oh, over hypotenuse. Sorry.
Yeah.
Um, so then this would be the h over, but we don't have, yeah, so opposite over hypotenuse. So we opposite is h, and the hypotenuse is a. So sine c is h over a.
Okay. And make H the subject.
So basically a, and then in a bracket, a times sine c.
Yeah. Or short for that is A sine C.
Yeah, equals h.
And then sub this expression into the area. So a half times base times height, or a half BH, that becomes what?
So that becomes a half a sine c, is it?
So a half times base, and we replace height with A sine C.
Okay.
And just to put them alphabetically, a half AB sine C. Yeah.
Okay.
So that's where the formula for the area of a rectangle comes from for when you don't know the height.
Okay. Could I copy that diagram down? Is that all right?
Yeah.
Okay, thank you. Yep, got that.
And so if you know what the height is, you can just do a half times base times height. If you don't know the height, you can do a half times A times B times sine C, where B is the entire base.
Okay.
And so it would be a half times one side times any other side times the sine of the angle between the two sides you picked.
Sure. Okay. Yeah.
Okay, exam question. You're given this formula. Find the area of this triangle.
Okay. Okay, so 66 and 7. Okay, so if we want the area of the triangle, so it's half AB sine C.
Mm-hmm.
And we basically sub in what we have. So we know, so our sine is 60 there. And then, so what we'd have is, which equals a half 6 times 7 times then sine 60.
Yeah.
And I'll just grab my calculator quickly. It's just
Okay.
okay. And then in the calculator that will be half times 6. That gives us 18.19 to 2 dp.
And so they say give your answer correct to 3 significant figures.
So that would be 18.2.
So that is 18.2. And you're right to put the whole thing into your calculator. So don't do a half times 6 is 3, because you might end up making some silly mistake.
Okay.
It's a calculator question. Just let the calculator do all the work. The formula is written out for you. Substitute into the formula and then put it all into your calculator and write down your answer.
Okay.
18.2. Okay, how about this one?
Okay, so that is, I'll draw that quickly. Okay, so the formula is half AB sine C.
Mm-hmm.
And that equals a half times 9.2 times 14.6 times sine 64.
Mm-hmm.
And that equals, I'll type that in again, so half times 9.2 times. That gives us 60.4 to 3SF.
Okay. And it's the area of the triangle, so it's meters squared. 60.4 meters squared. Any questions there?
No, that's fine.
Okay. X a half tick, area of a scalene triangle.
I think that's tick, that's fine.
Yeah. Okay, worded question.
Okay, so the flat bed in the shape of a... Okay, so that's it's equilateral, so that means that if three sides are 15, then one side is just 15 meters over 3,
Mm-hmm.
is 5 meters per side. And then the area. So then if we take, and we know that the angles in an equilateral triangle are 60 degrees.
Mm-hmm.
So if we want the area, we just use the half AB sine C again.
Okay.
Which equals a half times 5 times 5 times sine 60.
That's it.
That equals... That gives us 10.8 to 1 dp.
That's it. 10.8 meters
Meter.
squared. And got it. 3 marks. How about this one?
Area of a parallelogram. So again, 1 dp. So we could just have it. Okay. So if we just split this parallelogram in half, like along the line DB, to get 2 triangles. So because those 2 co-interior angles we know add up to 180 there, so the angle ABC and DCB. So we know the angle C would be 140 degrees. We have 5 and 7. So we use the half AB sine C.
Okay.
And then with that we get a half times 5 times 7 times sine 140. And I'll type that in. So that gives us 11.2 meters squared. Is it meters? It's centimeters squared to 1 dp.
And so what is this the formula for?
Which one? The area?
Yeah. The area of what?
The triangle. So we multiply this by 2, isn't it? So
Correct.
yeah. So without actually, because we have 11.2 there, we'll keep the calculator answer and then multiply that by 2. So answer times 2. So that gives us 22.5 centimeters squared to 1 dp.
Well done. Yeah, and you were right, because then you would get 22.4.
Yeah.
And this was 22.5. That's it. Yeah, you're correct. Because this is a parallelogram, the opposite angle is 40 degrees, and so these two must be 140.
Yeah.
Because it has to add up to 360, and minus 40 divided by 2. You said they're co-interior. They're not co-interior. That's for parallel lines.
Okay.
So, or perhaps that's what you were talking about, but
yeah.
I think you were talking about the triangle. Yeah, co-interior, 2 parallels.
Yes, Because if you could go back to that, is that all right? So because it's a parallelogram, surely A, B, and DC would be parallel.
Yeah, is that what you were talking about?
Yeah, with the co-interior thing.
Okay, yeah, if that's what you meant, then that's fine, yeah.
Because 40 and then 140 would be within. Do you get what I mean by that?
Yeah, like a parallelogram has 360 degrees. If you cut it in half, then it's 180, and there's no co-interior lines. There's no parallel lines in the triangle, and co-interior angles add up to 180.
Hmm.
These add up to 360. It's just if they were looking for reasons.
Yeah.
Okay, I want to do this one. So it's a difficult one. Any idea how we do this?
So I'll just draw that quickly. So that's to here. The upper bound for the area of the field. So these two these two lengths are to the nearest 5 meters.
Mm-hmm.
So if we just write the upper and lower bounds for this, so 225, the upper bound is going to be, because it's to the nearest 5, 230, and the lower bound would be 220.
So if you had 220 meters and you rounded it to the nearest 5 meters, what would it round to?
215.
I mean, I think it would round to 220 because that's a multiple of 5.
Okay, right.
And the way upper and lower bound always works, if you've got 225 is what it was rounded to, basically there's half of it that it could have been halfway below or halfway above.
Okay.
And so you always half the degree of accuracy, in this case 5 meters.
Mm-hmm.
And you add that and subtract that.
Okay. So half degree of accuracy.
So in this case, it's like 225 plus or minus 5 divided by 2.
Yeah, so we'd have 227.5 and 222.5 in this case.
Yeah.
For the upper and lower bounds. And then for 175, it's the same like degree of accuracy. So we have 177.5, and we also have 172.5.
That's it. So how does finding the upper bound for the area work?
So the upper bound of the area. So they want the highest number that the area could possibly have been.
Yeah.
Had it so we'd have to use the highest length, so the upper bounds for both those two lengths, and also the highest degree that it could have been. So that would be 50 in the upper and lower bound. So that would be 50.5, because it's to 1 degree, and then 49.5 degrees.
Well done.
So basically we use the highest value, so that would be half AB sine C. And then we just have a half times 227.5.
Mm-hmm.
And then multiplied by 177.5, and then times sine 50.5,
Well done.
which gives us I'll do that. So that gives us 155. So it's to. Did it say how many? Like the Does it want it to 1 dp or does it?
It doesn't say. Everything in the question is to 1 decimal place, so we'll do our answer to 1 decimal place.
Okay, so that would be 15579 0.6 meters. Meters squared.
Well done. 15579.6. 155. Okay, so they would accept anything in between 15,500 and 15,600. Okay. For an answer, 15,500 and 15,575. Okay, so anything between 75 and 80 they would have accepted. Yeah, but basically from 3 upper bounds. Yeah, so if you have to find the upper bound of the area, you use the upper bound for all 3.
Yeah.
And that method will always work, that you do the amount plus or minus half the degree of accuracy, because halfway below will round up and then halfway above is the upper bound, the upper fence. Any questions or anything there?
No, that's good. Got that.
Okay. So another tricky one. How do we do this?
30 x, and then that's 2x p cubed. The area is ACM squared, so they want to find that x is 2a. So half AB sine C equals the area, which is a squared.
Mm-hmm.
And then we just sub in the stuff for the AB sine C. So that would be a half of then 2x times x times sine 30 gives us a squared. And then we'll just simplify.
Hold on. I don't believe it's equal to a squared. They said it's equal.
It's a, yeah.
Yeah, centimeter squared or just a, yeah.
Okay, sorry, yeah. So then that's just a. So that would be a half 2x squared times sine 30 equals a. And then, so we want to get the x, so the x on its own here. So 2x squared.
So what is a half times 2x squared?
Oh, that's just x squared.
So that's going to be x squared times sine 30.
Yeah.
This is a calculator question. What is sine 30?
It's a half, so that gives us 0.5.
Okay.
So that would mean, so 0.5x squared equals a. So then x squared is 2a, and then x is root of 2a. That's the answer.
X is that it. That's it. So this was just pure algebra. You write down the formula, area equals a half AB sine C, sub into the formula, fully simplify, and then rearrange to make x the subject.
Yeah.
Any questions about that?
No, that's good.
And you know how when you have x squared equals 2a and then you square root both sides, why is this not plus or minus the square root of 2a?
Because if we think, so if we had minus, like let's say minus 2a squared, that would give us, they both give 4.
So you know how if you have x squared equals 9,
yeah,
x can be 3 or x can be minus 3.
Yeah.
So why is this not, plus or minus the square root of 2a?
Trying to think. So if we had to
It's okay.
No, I don't know.
It's because you can't have a negative area or a negative length.
Oh, right. Okay.
And so just in the context of the question, this can't be minus 5 centimeters long. The area can't be minus 20 centimeters squared or anything. So that's just why there's no plus or minus on that one.
Okay.
X a half tick area of a scalene triangle for 3 mark questions.
I think so. That would be a tick there.
Yeah, I agree. Okay. Work out the area of the pentagon.
Okay, so I'll draw that pentagon. So and so with a pentagon there, it's equilateral because they're so they're 5 isosceles. Yeah, it's a regular pentagon, and so that means that this 6 meters, and the fact that they're isosceles triangles tells us that all of those lengths going into the center row would be 6 meters.
Mm-hmm.
So we can just label the side next to it. So BO. Oh yeah, you could do that as well. So
Okay.
So 5 isosceles triangles. Okay, and then if we want the length C for this, so that will be the length between those two sixes. We just have because it's 360 divided by 5 because it's equilateral. So that gives us 72 degrees for each C. So I could put 72 degrees. So half AB sine C. So that's our formula. So that equals a half of 6. So half times 6 times 6 times sine 72. And I'll type that in. So half times 6 times 72 gives us 17.119. That's to 3dp. But we need, it's a pentagon, so that's one of the triangles. Mm-hmm. So we just have answer times 5. And so I'll just times it by 5. And you get 85.6, is it meter squared, yeah.
That's it. 85.6 meters squared. Any questions there?
No, that's fine.
Okay, yeah, and so you can see the center, the 5 angles make a circle, so they add up to 360. They're all the same. Divide them by 5, 72 each. X a half tick 4 mark questions.
I think that's tick.
Okay, sine rule. So those are the ones that are just the area. Sine rule. In the triangle on the left, find sine of the angle B.
So sine B equals, so sine is opposite over hypotenuse. That equals sine is H over C.
And is equals H over C. And then make H the subject.
So basically, so sine is H over C. H is C sine B.
C sine B. Okay. Same idea for in the triangle on the right for the angle C. Find sine C in terms of H and B.
So sine C equals, again, the opposite over hypotenuse, which is H over B.
And then make H the subject.
So then H is B sine C.
And then equate the two expressions. So H equals C sine B. H also equals B sine C. How do you equate those two? How do you make those equal to each other?
So basically, C sine B equals B sine C.
Yeah, because they're both equal to H, so they must both be equal to each other. B sine C equals C sine B. And then how can you show that B over sine B equals C over sine C?
So if you divide, so you can get, so you want B over sine. So sine C over C, no, B sine C over C equals sine B.
Yeah, I'm just gonna divide both sides by sine B sine C.
Okay, right.
So just do the whole thing in one go.
Yeah.
And what would happen there?
So then you get B sine C equals C sine B there. B sine B, sorry, equals.
Yeah, basically sine C over sine C cancel each other out. So B over sine B. And what happens on the right?
C over sine C.
Yeah, the sine B over sine B cancel each other out. So it's just you can do it all in one go. It's a crazy way to do it. Yeah, so this is called the sine. You could repeat this as well for the angle A, and you would find out that that is also equal to A over sine of the angle A. And so basically that means any side divided by the sine of the angle opposite it, because it's sine opposite over hypotenuse, any side over the sine of its opposite angle is equal to any other side over the sine of its opposite angle.
Okay. Could I copy all that down? Sorry. So.
Yeah. So that's just how you prove it.
Yeah. Sine. Okay, yeah, got that. Sorry.
Okay. Okay, so this is the formula that's given to you. Find the length of x to one decimal place.
So using that rule, so A over sine A equals B over sine B.
Mm-hmm.
And so the angle's there. So that would mean that x over sine 75 equals 10 over sine 25. And then x equals 10 sine 75 over sine 25.
That's it.
And then we get the answer. So that's we get 22 points. Does it say 1 dp? So 22.9. Is it?
Doesn't.
Centimeters. Or...
Yeah, just units, whatever it is. 22.9. Got it. Okay, how do you do this one?
Then 8 here. So we're not given the sine opposite to x, but we know sine angles in a triangle that add up to 180. So 180 minus, and then in a bracket, 37 plus 63 gives us 80 degrees there.
Okay, and I think you'll be fine for the rest of that.
Yeah.
That's the only trick there. And then it's just x over sine. In fact, you could probably just say x equals, so the other one was 8, and that's sine 80, and the 8 was over sine 37.
Okay.
Yeah, I think you're fine for the rest of that. That's a tick. Okay, find the area of this triangle.
That's 620. Okay, so we're given that. We're given the angle, and then so we need the side opposite to either the angle C or angle B. I'm trying to think, is it an isosceles triangle? Do they give that to us? Or oh no, we could probably prove. So the other angle is 35 degrees. So it's not an isosceles triangle.
Okay.
So what else could we we could use trigonometry to find the other side, the other. Oh no, but it's not 90 degrees, is it? So
How else can we find the missing side in a scalene triangle?
we could use the we could rearrange the area formula, or we could. Oh no, but we don't. Is that another rule, or is that just?
How did we find the length of a missing side here in a scalene triangle?
Oh, we used x for that and then rearranged it. Oh yeah. Okay.
So what side do we need here?
Work out the area of triangle ABC. We need side CB because we want the area.
Okay.
So we label side CB as x or whatever. So then, okay, so x over sine 35 equals 6 over sine 25. And then x equals just 6 sine 35 over sine 25, which is that gives us so 8.1. I'll put 143. 8.143.
Yeah, that's fine.
Then, we got the length of that side. So we want the area. So the area is half AB sine C. That gives us a half times 6 times 8.143 times sine 120.
Well done.
And then we just get the answer for that. So half times 6 times sine 20 gives us 8 point, so it wants to 1 dp, so 8.4 cm.
8.4 centimeters. And so this uses 21.2. Where did we go wrong there? Did you do 6 sine 35 and then divided by 25? So 6 times 25 sine of that. Yeah, so that is that divided by sine 25. So that's 8.143. That's fine. And so a half times, okay, so 0.5 times 6 times 8.143 times the sine of 120. I get 21.2. Did you put it in your calculator wrong?
Yeah, so yeah, I got there was an extra zero on no, it was, for the sine 20 I had I did sine 20, not sine 120 there.
Okay, so it's just a misread. Yeah. You said 120. I think you just pressed wrong one.
Okay.
Yeah, any questions about that?
No, that's fine.
Okay, so sine rule is for you can use it to find a missing side in a scalene triangle. So SOHCAHTOA is for right angle triangles. 4 mark questions, sine rule?
I think that's a tick, but I could probably do with a bit of practice.
Okay, so area for this triangle.
Okay, so yeah, we can use the sine rule again for this to find the missing lengths. So I'll draw the triangle. .7 and 649 6 4. So then we want a side next to an angle, so you can find AC. So then you can have, if we label AC to be x, we could have x over sine 49 equals 8.7 over sine 64. Then we just have, so x equals 8.7 sine 49 over sine 64, which gives us, I'll type that in, so that gives us 7.3053. And so we have the length, so we want the angle between those two lengths. So we could just have 180 minus 64 plus 49, and those two in brackets. So then we have 180 minus 64 gives us 67 degrees. So yeah, we have 67 there. So then we can have the half AB sine C, which equals a half times, we'll have, so half times 8.7 times 7.3053 times sine 67, and then that equals times 3053. 29 point. It's to.
We'll do
I'll
it.
say, sorry, what?
We'll do it to 3SF.
Okay, so then, yeah, so 0.3 cm squared.
That's it. And yeah, so 8.7 is to 1 decimal place. So this 1 decimal place. They gave us the question to 1 dp. 29.3. Yes, you did that all by yourself. 5 marks. So that was your practice. You didn't need my help. Any questions there?
No, that's good. Got
Yeah,
that.
you got it for sure. Okay, so this one, show that A sine B equals B sine A.
Okay, so then. So it's like rearranging. So A over. So A over sine A equals B over sine B. So sine B. So B sine A over, or we could just multiply both sides by sine B sine A.
Yeah.
Like you did for the previous one. So A over sine A times sine B sine A equals B over sine B times sine B sine A. So then we have basically B sine A. B sine A equals A sine B.
And then you can just cancel down.
Yeah, so then, what is it? So they want A sine B equals B sine A. Yeah, so then B sine A equals A sine B or whatever.
Yeah, so just cancel down sine A over sine A, sine B over sine B, and then show that sine A over A equals sine B over B.
Okay, so then sine A over A equals sine B over B. So then we could divide both sides by so divide both sides by AB. So B sine A over AB equals A sine B over AB, and we cancel it down, so then we have sine A over A equals sine B over B.
That's it. Sine B over B equals sine A over A, and you can just swap them around. And what that shows you is that at the very top we had the sides on top and the sines of the angles on the bottom. Now we have the sines of the angles on top and the sides at the bottom. If you have to find a missing side, it's easier if you start with the sides on the top. If you're trying to find a missing angle, it's easier to start with the missing angle on the top. It's just less work.
Okay. So missing side, you use the side on the top, was it?
Yeah.
Okay.
It's easier if it's at the numerator.
Okay.
Okay, find the missing angle x.
Okay, so then I'll draw that quickly. That's x, then 2, then 8, and 7 here. So then we can use the rule. So sine A over A equals sine B over B. And then we can we use sine x over 7. Yeah, sine x over 7 equals sine 72 over 8 here. And then if we want x on its own, so you have sine x equals sine, so 7 sine 72 over 8. So then x is just arc sine, so sine to the minus 1 of that whole thing, so 7 sine 72 over 8. And then I'll write that down. So and we get 56.3 to 1 dp.
1 dp. That's it. And yeah, so 56.3. So there were 2 steps. One was multiply by 7. The other was inverse sine. If you started with the angles on the bottom, then there would be either 3 or 4 steps instead of just 2. X a half tick, finding an unknown angle using the sine rule.
I think that's a tick.
Yeah,
okay.
It's not. The real trick is in selecting what you need. Okay, how do we do this? Calculate the length of LN.
Okay, so that one. So for LNM. So then okay, so the angle L, the length LN. Okay, so that's, if we mark that X, so then we can have okay, so and okay, so I'm thinking, so we could have sine, so A over sine A equals B over sine B. And then so we have 12.8 over sine X, no, sine A, we'll keep it sine A, equals 15.7 over sine 136. So then we want sine A, so we want A on its own to get that angle. So then...
so you're trying to find a missing angle, is it?
Yeah.
So what would be easier then?
If we just reciprocated both of these, so then sine A over 12.8 equals sine 136 over 15.7. So sine A equals sine 1, so 12.8 sine 136 over 1 over 15.7, and then A is just the sine to the minus 1 of 12.8 sine 136 over 15.7, and then I'll calculate that. So we get 34.4958 for the angle there in degrees. So yeah, so we need the other angle. So if we want to find LN, we need the angle NML. So basically we have 180 minus, and then in brackets I'll put answer plus the other angle 136, and we get 9.5, so 9.504 degrees there.
Okay.
answer. So yeah, answer plus 136. So then we have just so we need this. Now we want the side, so we just have a over sine a. So a over sine a equals b over sine b.
Mm-hmm.
And then we have the a being x, so we could have x over sine 9.504 equals 9.504 equals 15.7 over sine 136. X is 15.7 sine, then in brackets 9.504 over sine 136. And we get in centimeters. Wait, so we 15.7. Yeah. 15. 9.5. Sorry, so we get 3.7. Is it, what does it say? 3SF. 3.73 centimeters for that length.
And that's 3.73, and that's 5 marks.
Cool.
Yeah, so you got that all yourself. So in this case, you had to use both the reciprocated one with the angles on the top, and then the other one with the sides on the top. Any questions there?
No, that's good. Got that.
If this is to 3, if the answer is to 3 significant figures, how many significant figures do you need in the working out?
Is it 5?
Yeah. So here you used 6. Nothing wrong with that. You can get away with 5. You only ever need 2 more.
Okay.
So this one, calculate the area of this parallelogram. It's very similar to what you just did, and then you times your answer by 2.
Cool.
Yeah.
Then
this one is similar triangles. It's a tough one. It's a very tough one. We just don't have time for. Yeah, so x a half a tick. That was 5 mark question.
I think that's a tick. I think that's cool.
Okay, so we got a lot done. So this is the hardest type of trig. We didn't get onto cosine rule, but basically, yeah. So we started off with a half times base times height. And we rearranged a triangle to prove that area is a half AB sine C. So basically, if you know the height, use a half times base times height. If you don't know the height, use a half AB sine C. And most of the time when you know the height, it's because it's a right angled triangle, and when you don't know the height, it's because it's a scalene triangle. A half AB sine C will work for any triangle. That's the good thing about a formula for a scalene triangle. It'll work for isosceles, equilateral, right angled, or scalene, or anything. So then we did worded questions, so 2 marks, 3 marks. Yes. So how do you find the upper and lower bound of a measurement?
So basically, you have the upper bound is half of the so the correct to the nearest number. So it's 5 there. So we'd have to find half of that number. So we'd have 2.5 there, and just add that to our original value for the upper bound, and then minus that from the original value for the lower bound. That's
it. So I'm just going to boil that down to the rounded value plus or minus the degree of accuracy divided by 2. I'll give you the lower bound and the upper bound. So we did this rearranging one. So we did lots of revision of harder stuff as well. When I say it's a revision type question, it means that it involves more than just one thing. So it involves something that we're not learning today. So this is every past exam question. So you did all of them for that. Yes. So we proved, any side over the sine of its opposite angle is equal to any other side over the sine of its opposite angle in scalene triangles, and so that will work for any triangle. If it's a right angled triangle, it's easier to use SOHCAHTOA. The easiest is Pythagoras, and then this stuff is the most challenging, and you only use this when you absolutely have to, which is when it's a scalene triangle. So this was finding the unknown sides. When do you have the sides on the top? When do you have the angles on the top?
So you have the sides on the top when you're looking for a side, and the angles on top when you're looking for an angle.
Yeah, it just makes it easier. That's all it is. So then we did both of them together. So find an unknown side so that you can find the unknown angle. So we proved there that you can reciprocate both and that works. And then so this used both of them together. And yeah, how did you find that, Stefan?
That's good, I think. If you could email the slide, as normal, the slides, and then maybe the questions, and if you can, maybe some more, just so I can really practice, because I'm on holiday this week, so I can get more work done, I think.
Okay, I'll email those. I'll email them now. Any question? Anything in particular you want to do next time?
Nothing in particular, no.
Okay, so I think I'll pick I'll check if cosine rule is there, but I'm sure we've covered this bit anyway. And any questions for me in general?
No, that's fine. I'm all right.
Okay, well done, Stefan. You did great. I look forward to chatting again on Thursday.
Thursday, yeah. Thank you.
Right.
Also, just for Thursday, if you could call me on the Stefan Luangama account, is that all right?
Yeah, that's fine. Yeah.
Okay, thank you. So see you on Thursday.
All right. Have a good one, Stefan.
You too. Bye-bye.
Bye.